Would you please tell me if that is true? Would you tell me if that is true? Is that true?
Yes.
All right, excellent, excellent. I knew this was an advanced class. If I choose to take this one by 5, is that equation still true? No, it is not true. It is breaking mathematical laws. If I take that one times 5, is the equation still true? No, it is not. How about if I take all of them by 5? Is the equation still true? Is it now true? So if I do exactly the same to everything, I mean, are the numbers bigger? Sure, but is the equal still true? Let me see. 5 times 2 is 10, plus 5, it is 15. So if I do the same thing to every single part of an equation, it stays equal. I mean, they might be bigger or smaller, but they're still equal. All right, well, I can't imagine there is any person around here who just loves fractions unless you love fractions, in which case you would love fractions. So here I think is the first problem. A little hint, when you're writing it down, leave a little room there. Now, if I were to use the old school word common denominators, if I was to say common denominators with 9 and an x and I, what would that common denominator be? Hi. Oh, look who's back. Yeah, hi. Have a seat and learn. Yeah, cool. What would the denominator be? What would the common denominator be? Someone say 9x and show off for our visitors.
9x.
9x. Have I right now broken any mathematical laws by taking that times 9x? Are they still equal? No. What if I take this one times 9x? Hey, Mac, Jada, if I take all of them times 9x, is it okay or not okay? It's okay. It's okay. So these might be worth more, but now it's okay. Now watch what always happens, and this is cool because not many of us like fractions. It always works. 9 and 9 cancel out, and you have x times 1 with no fraction. X and x cancel out, 1 times 9, and the 9's cross out, and we get a 4x. All of a sudden, does that problem go from to easy? Cool, I mean, take away x and cool, all right. Are you two supposed to be anywhere? All right. Take away x is probably 3 or something like that. All right. How many of you knew that when I first put the problem up there? All right. How many now know it? Okay, cool. I know it's not easy to learn via video. This is not done. Take away x and then divide by 3. Cool. Let's look a little further down the page. Like letter E. We got 8 times 5 over 5x minus 2, 3x. Let us pretend like we are just looking at common denominators. Jada, what's the number part of common denominators? What happened to your skin? It seems darkened. Have you been gone? Oh, you were gone. That's why your skin is darkened. Okay. All right. Is the number part 15? Is the x part x? If someone said common denominators, shake your heads. Okay. I'm going to take this times 15x over 1 times 15x over 1 times 15x over 1. Have I broken any mathematical laws? Have I broken any laws? No. So what I could do, x's cancel out, and 5 goes into 15 3 times. This whole mess is just 3 times 8, which is 24. The x cancels top and bottom. 3 goes into 15 5 times. Careful, negative 2 times 5 is minus 10. And the 15's cancel out, and we get 4x. And now you have to finish it, but is that problem gone now to quickly an easier problem? to a quickly and easier problem. Am I getting heads shaken that either you did know this or now it's good? All right, good, good, good. All right. I'll pause. Am I done pausing? Okay, I'm done pausing now. So, yeah, finish it up. All right. Do you remember the words least common denominator from when you were younger? The least common denominator? If we use the least common denominator, it's going to make the problem just less big numbers. So I'm going to look at problem I. 1 over y plus 3 equals, hint, leave some room, 7 over y minus 3 minus 2 over y squared minus 9. Well, it looks like the common denominator would be y plus 3, y minus 3, y squared minus 9. But the first unit in this class started with the letter F and it ended with tor. It is factor. Factor. Let us consider factoring over there. And I'm going to factor, and I'm going to be lazy. Boo. Squared minus a squared. Squared minus a squared is going to be y plus 3, y minus 3. Okay, that was too lazy of me to do that. All right. Now once we've factored, we get a least common denominator, which means the problem just doesn't get huge. In fact, the common denominator would be y plus 3, y minus 3. Say yep?
Yep.
So now take this times y plus 3, y minus 3. Take this one times y plus 3, y minus 3. The more that you consider leaving room, y plus 3 or y minus 3. We've not broken any mathematical rules. We've not broken any mathematical rules. And something really awesome is about to happen. The y plus 3's can cancel. And we have 1 times y and 1 times minus 3. On the first one, the y minus 3 cancel. We've got the distributive property, 7 times y, 7 times 3. And this part's the part that's the most awesome. They both cross out. And what you got there, and what you got there, and what you got there is no fractions. And I doubt anyone in this class is now stressed out, is now not stressed out. Well, there is one good thing about where we're at mathematically with my necessary absence, is that this was planned to be a 2-day lesson. So today's lesson is going to be remarkably similar. It's going to be remarkably similar. And because it's wind day, we should have plenty of time. When I've given this worksheet about the sheep, before, kids say, there's not enough room on the worksheet to do it. I tend to agree with them. Our second worksheet, how long do I need to? I'm gonna make a second video, so just